And last time we have discussed the refraction of light and refraction through a glass slab and multiple slab also. Next topic, that is spherical lenses. Spherical lenses means a lens is a transparent material medium bounded by two curved surfaces. Transparent here, that medium should be a transparent and homogeneous medium. It is better homogeneous. It is better. Generally, it is sufficient transparent medium which is bounded by two curved surfaces, that is lenses. And lenses which are classified into following categories means one spherical lenses which are classified one spherical surface and other that is a plane surface. In case of this, that is a plano-convex lens, means in that case just you see the figure of plano-convex lens, means like that. This one is a means that is a plane, and it is a means one side which is a convex, that is a plano-convex lens. एंड प्लेनो कॉनकेव लेंस मीन्स सेम वे, मीन्स यहाँ पर लेंगे हम, देखिए कॉनकेव लेंस, दिस वन फर्स्ट ऑफ ऑल वी ड्रॉ द कॉनकेव लेंस एंड दिस वन that is a concave lens, and just you divide this lens into two parts, and this one portion, this one is a means one surface that is a curved, another surface that is a plane, that is a plano concave lens. And next both spherical surfaces. Okay, first of all let me remove it. Both spherical surfaces means there are two types of lenses, means concave lens and convex lens. And next, convex lens means which is thinner at the edges and thick at the middle, and it is thin at the edges, and there are two refracting surfaces, spherical surface 1 and spherical surface 2, and it is also known as the converging lens. A convex lens is made up of a line joining two spherical surfaces in such a way that it is thicker at the center and thickness gradually reduces as we move towards the edges, and that is also known as the converging lens, because when light rays strike on this lens and these light rays all are converged at a point, so this lens, that is also known as the converging lens. Next we will discuss about the concave lens. Concave lens is just opposite to a convex lens. It is thicker at the edges, means this one edge and this one edge, but it is thin at the middle part, and it is known as the diverging lens, means parallel beam of light is strike on this lens. After the refraction, these light rays are refracted, diverge, and these are appear to meet at this point. So this lens is known as the concave lens. Here there is a difference between the spherical mirror and lens. Spherical mirror means image formed by the reflection. Here there is a refraction, and spherical mirror has only one focus, whereas the lens has two focus, and center of a spherical mirror is termed as pole, and it is known as the optical center. Here we are using, there are some terms associated with the lenses. Yes, next topic, that is terms associated with lenses, means what are the terms used in a lenses. Here there are two lenses, that is a concave lens and it is a convex lens. And first of all, that is the first heading, that is a optical center. The midpoint of a concave lens, that is the optical center, means just you see this point, that is the midpoint of this lens, that is called optical center, and it is the midpoint of this lens, that is called optical center. And center of curvature, the center of a sphere from which lens is taken out, that is the center. center of this sphere from which this lens is taken out, that is called center of curvature. Same way, the center of a sphere, center of a sphere from which that lens is taken out, that is called center of curvature. And the distance between, next thing, that is distance between center of curvature and optical center. Optical center, that is called radius of curvature, that is a small r. That is this point, that is that distance is known as the radius of curvature, and this one, that is radius of curvature. Similarly, the distance between this point to this point, that is called a radius of curvature. It is radius of curvature. Next, principal axis. Principal axis, yes. Principal axis, a line joining the optical center and radius of curvature, that is called principal axis. Means that line joining the this one, or you can say the straight line joining two center of curvature of optical center is called principal axis. Next, means here there is also a explanation, center of curvature first and center of curvature second, and it is the optical center. These are joining by this line, that is called principal axis. Same way, and this one is a principal axis for a concave lens. And next thing, we must know about the focus. In case of here, we hold a convex lens, and when sunlight falling upon it, we focus a point, you will find a bright spot appear on a wall or on a paper. Means, can you explain the formation of this bright spot? Light after the refraction converges at a point, and that point is called focus. Here I have written the definition of the focus. Means when parallel beam of light incident on a convex lens, on concave lens, after the refraction they actually meet at a point, that is called focus, or appear to meet at a point, that is called focus. Here means the image found at a focus and image found at the concave focus by a convex lens and concave lens, we will discuss later on. And next, that is a refraction by spherical lenses. For the refraction by spherical lenses, there are mainly three laws. Means the first law, when light ray parallel to the principal axis, after the refraction it passes to a focus. That is the first rule in case of a convex lens. Next, in case of a concave lens, light ray that is parallel to the principal axis, after the refraction it diverges, because it is a diverging lens. Concave lens is a diverging lens. Here light actually meet at a point focus f2. Here actually meet at a point, appear to meet at a point focus f1. That is a first rule. Next, that is just opposite to this rule. When light ray passing through a f1, means first focus, after the refraction from a convex lens it becomes parallel to the principal axis. In next case, in case of a concave lens, light ray strike on a concave lens like that, means obliquely, and after the refraction it becomes parallel and it appear to meet at point focus f2. And next, third rule, when light ray passing through a optical center, it is not deviating, means in the both the cases. So these are the rules for the image formed by the concave lens as well as the